Lesson: Risks from distributed denial of service (DDoS) attacks. Distributed denial of service attacks represent a significant threat to the stability and security of digital infrastructures, including those in blockchain and artificial intelligence environments. These attacks aim to overwhelm a target system, such as a web server or a blockchain network, with a flood of internet traffic, rendering it unable to process legitimate requests. The implications of DDoS attacks are profound, often resulting in financial loss, reputational damage, and operational disruption. Given the critical nature of blockchain and AI systems in modern enterprises, understanding and mitigating the risks associated with DDoS attacks is essential for professionals tasked with safeguarding these technologies. DDoS attacks exploit the distributed nature of the internet, utilizing multiple compromised computer systems as sources of traffic. These attacks can range from simple volumetric attacks, which saturate the bandwidth of the target, to more sophisticated application layer attacks that mimic legitimate user traffic but in overwhelming volumes. In the context of blockchain, a DDoS attack can prevent nodes from participating in the network, disrupt the consensus process, or even lead to a temporary fork in the blockchain. Similarly, AI systems, particularly those deployed in cloud environments, can suffer from significant performance degradation and increased latency, affecting the reliability of AI-driven applications. To address these risks, a multi-layered defense strategy is crucial. One effective approach is the implementation of robust network architecture that can absorb and deflect attack traffic. Cloud-based DDoS protection services, such as those provided by Cloudflare or AWS Shield, offer scalable solutions that can automatically detect and mitigate DDoS attacks. These services leverage global networks to disperse attack traffic and protect the integrity of the target system. By integrating such services into the cybersecurity framework of blockchain and AI systems, organizations can enhance their resilience against DDoS threats. Another practical tool in combating DDoS attacks is the use of intrusion detection systems and intrusion prevention systems. These systems monitor network traffic for signs of suspicious activity and can automatically block malicious traffic before it reaches the target. For instance, Snort, an open-source IDS/IPS, offers customizable rule sets that can be tailored to the specific needs of blockchain and AI environments. By continuously analyzing traffic patterns and identifying anomalies, IDS/IPS can provide early warning of potential DDoS attacks, allowing for rapid response and mitigation. Additionally, rate limiting is an essential strategy in controlling the impact of DDoS attacks. By setting thresholds for the number of requests a server can handle from a single IP address, organizations can prevent any one source from monopolizing network resources. This technique is particularly useful in protecting against application layer attacks, where attackers attempt to exhaust server resources by sending legitimate-looking requests at high volumes. Implementing rate limiting requires careful calibration to balance security with user experience, ensuring that legitimate users are not inadvertently blocked. Blockchain networks, due to their decentralized nature, present unique challenges and opportunities in the context of DDoS protection. One effective strategy is to increase the network's redundancy and decentralization. By distributing nodes across multiple geographic locations and network providers, the impact of a DDoS attack on any single node can be minimized. Furthermore, blockchain-specific solutions, such as the Lightning Network for Bitcoin, can help mitigate DDoS risks by offloading transactions from the main blockchain, thereby reducing the attack surface. The application of AI in detecting and mitigating DDoS attacks is another promising avenue. Machine learning algorithms can analyze vast amounts of network traffic data to identify patterns associated with DDoS attacks. These algorithms can be trained to distinguish between normal traffic fluctuations and malicious activities, providing an adaptive defense mechanism that evolves with the threat landscape. For example, AI-driven security platforms like Darktrace use machine learning to detect and respond to cyber threats, including DDoS attacks, in real time. By leveraging AI, organizations can enhance their ability to anticipate and counteract DDoS threats proactively. Case studies highlight the efficacy of these strategies in real-world scenarios. In 2016, the Mirai botnet launched one of the largest DDoS attacks in history, targeting DNS provider Dyn and affecting major websites like Twitter and Netflix. The attack exploited IoT devices with weak security, underscoring the importance of securing all network endpoints. In response, many organizations have adopted IoT-specific security measures and enhanced their DDoS protection capabilities. Similarly, in 2020, a major European blockchain platform successfully thwarted a DDoS attack by deploying a combination of cloud-based services and AI-driven detection systems, demonstrating the effectiveness of an integrated defense approach. Statistics further illustrate the growing threat of DDoS attacks. According to a report by NetScout, the frequency of DDoS attacks increased by 20% in 2020, with the average attack size exceeding 1 GB per second. This trend highlights the need for continuous vigilance and adaptation in DDoS protection strategies. By staying informed about the latest attack vectors and protection technologies, professionals can better safeguard their blockchain and AI systems against this pervasive threat. Continuous monitoring and incident response planning are also critical components of an effective DDoS defense strategy. Organizations should establish comprehensive monitoring solutions that provide real-time visibility into network traffic and performance metrics. Tools such as Splunk or ElkStack can aggregate and analyze log data, enabling rapid identification of anomalies and potential threats. In conjunction with monitoring, incident response plans should outline the steps to be taken in the event of a DDoS attack, including communication protocols, roles and responsibilities, and escalation procedures. Regular drills and simulations can help ensure that response teams are prepared to act swiftly and effectively when an attack occurs. In conclusion, the risks posed by DDoS attacks to blockchain and AI systems are significant, but they can be effectively managed through a combination of strategic planning, technological solutions, and continuous adaptation. By implementing cloud-based protection services, leveraging IDS-IPS, applying rate limiting, enhancing network decentralization, and utilizing AI-driven detection tools, organizations can bolster their defenses against this pervasive threat. The integration of these strategies within a comprehensive cybersecurity framework will not only protect blockchain and AI systems from DDoS attacks, but also enhance their overall resilience against a wide range of cyber threats. By staying informed and proactive, professionals can ensure the security and stability of these critical technologies in an increasingly interconnected world.